Another sound problem, fairly simple. We've got a pipe. We're going to deal with two different situations, open at both ends or open at one end, closed at one end. And we're looking at the fundamental frequency in the first two overtones. So let's take a look here. First we'll do open at both ends. And the fundamental frequency, here's our pipe. That's sort of a cross-section of the pipe. The fundamental frequency is going to look something like this because it has to have an antinode at each end of the pipe. An open pipe has to be an antinode. A closed end has to be a node. So there's our lowest frequency that makes a standing wave in a pipe open at both ends. And let's see, I'll just do the calculations right underneath it, I guess. What we've got is the velocity is wavelength times frequency. That's true for any wave. It's true for sound waves, mechanical waves, light. Velocity is lambda to f. And we know in this case the length of our pipe, L, has to be equal to half of a wavelength, right? 1/2 lambda. Because we start at this end at a maximum, we go down to a minimum. If we could continue, that would be the rest of our wave. That would be one wavelength. So the pipe is half of a wavelength. The length of the pipe is half the wavelength. So this tells us the frequency is V over lambda. V is given, 344 meters per second. Lambda is going to be 2L. L is half a meter. So 2 times a half is just 1. So 344 hertz, or 344 cycles per second, is the frequency that gives us this standing wave. Now let's take a look at the first overtone, or another way of saying that is the second harmonic. Here's our pipe. And that's the pattern that gives us a standing wave. And so the length of our pipe now is equal to the wavelength. You can see we're starting at a maximum, we come down to a minimum, and we come back up to a maximum. So that's one complete cycle. That's one wavelength, and the length of the pipe equals the wavelength. Since the frequency is V over lambda, we get 344 over a half, which is 688 hertz, 688 inverse seconds, 688 cycles per second, different ways of saying the same thing, the units for frequency. And let's look at the second overtone, or the third harmonic. Here's our pipe. Open at both ends. And let's see, we're going to get something like that. So the length of our pipe now is going to be, starting here, we go 1 full cycle plus a half. So the length is equal to 1 1/2, 3 halves. The wavelength, 1 1/2 wavelengths. So that tells me the frequency is V over lambda, 344 over 2/3 times a half, 1032 hertz, 1032 cycles per second. So that was a pipe open at both ends. You could probably do closed at both ends. You'd get the exact same numbers. The pictures would look a little different. Instead of having an antinode at each end, you'd have a node at each end. But the pictures would actually look similar except for that condition. The numbers would be identical. So let's take a look at what happens now if we have open at one end only. Our fundamental is going to look like this. A node at this end and an antinode at the other end. So the length is going to equal 1/4 of a wavelength. You should be getting pretty good at spotting these by now. That means that our frequency is going to be 344 over 4L, which is 172 hertz. And then the first overtone, or the third harmonic. And the reason we're skipping the second harmonic is because we have different conditions at each end. We have a node at one side and an antinode at the other side. If you remember up here, we had antinodes at both ends. We had all of our harmonics, the first, the second, the third. If it was closed at both ends, we'd have all of the harmonics. But when they're opposite, you only get the odds. So this is going to look something like this, where the length of the pipe is 3/4 of a wavelength, and that means their frequency is going to be 344 over 4/3 times a half, 516 cycles per second. And the last thing we were supposed to find was the second overtone, or the fifth harmonic. And it looks something like this, where the length is 5/4. So we do one complete cycle, 1 1/4 wavelengths is the length of the pipe. And we plug in our numbers. I got 860 hertz for the frequency. So get used to drawing these pictures and looking at them and seeing them. Do pipes open on both ends, closed on both ends, open on one end, and just get used to seeing the pictures and spotting the length relationship with the wavelength.